I'll continue with AP, arithmetic progression. And the last example will say if you have 2x, y, and 17, how do you determine the values of x and y? See what we've done first of all. Here is the first term. Here is the first, second, third for this first, second, third, and fourth term. And this is the fourth term. So I know my first term and my fourth term. We discussed last time that if you want anything, say L equals A plus N minus 1. That's a common difference. Like if I want the second term, my N will be 2. You're going to have L equals A plus 2 minus 1 times D. L equals A plus 1D, which is D for the second term. Now for the fourth term, if I want the fourth term is LA plus N minus 1 times D. But if I say the fourth term, here N will have be 4. So when I have L equals A plus 4 minus 1 D. And that will give me A plus 3D. What I want to prove here is that any term you want, for any n term, A must be there, plus the number of D means the nth number you want minus 1. That is another, I want some D here, but what will be in front of D? What is the coefficient, the number of D I want? The formula says, whatever term you want, minus 1 to get to this. So like the second one now, the second one, our n is 2. So 2 minus 1 will be just 1D. Now for the fourth term, here where n is 4, say 4 minus 1, that's 3D. That's why John do not say, for any time say A plus n minus 1 times D. Now, having been given the first and the fourth term, I'm going to form equation now to be able to determine the value of x and the value of y. And to do that, I'll be able to determine what is that. That is D. What is D? So now say A, we know A here. A is 2. The fourth term equals A plus 4 minus 1, 3D. But then you are told that this fourth term is known already to be 17. In other words, it will now equal to 17. If we now say that A plus 3D equals 17, I will know A to be 2. I can now solve for D. Since A is 2 from the equation here, my A is 2. It becomes 2 plus 3D equals 17. Like subtract 2, subtract 2. So my 3D equals 17 minus 2. And therefore 3D equals 15. I want my D now divided by 3. Both sides 3, 3. 3 goes there. Therefore my D equals 5. In other words, I am adding, if it's not minus or plus, it means I am adding 5. If I now want the second term x, and I come back here, I want to get the second and the fourth and third terms. For my second term, 2 methods. You can say 2 plus 5, since we're adding 5. That's x equals 2 plus 5, which is 7. Or, and I say, or, my second term equals A, and last term, A plus 1D. Second term equals A plus 1D we got last time. Because I said third term equals A plus 2D. So second term is just A plus 1D. That's what we're going to do for third term. I now know that my A is 2. I'm giving that A is 2. Plus, sorry, my A is 2. So take it as 2 plus my D say I am 5 plus 5. Therefore 7. That's why X equals second term, which is X equals 7. Then what happens to get my third term? My third term, which is what? It could be in the third term, you cannot say it's 7 plus 5. Since I say plus 5 plus 5, the common difference is 5. That is 12. Alternatively, you cannot say third term equals A plus 2D. From this because it is the term you want minus 1, A plus the term you want minus 1D. Since I want the third term, A plus 3 minus 1, 2D. I know my A to be what? To be 2. We know from the equation A is 2. So this means 2 plus 2 times D. And we've gotten already that the common difference D is 5. 2 times 5. 2 times 5. 2 plus 2 times 5, 10. And that will give me 12. And that is value for y. But which is third term, which is y equal to 12. Therefore, my x and y, I've now got it. Finally, my x equals 7, y equals 12. Yeah. X here is 7, y is 12. Because I am adding 5 plus 5. 2 plus 5, 7. 7 plus 5, 12. 12 plus 7. 12 plus 5, 17. If I keep on, maybe the next 3 times will be plus 5. Keep on. If I add 5, I get 22. Add 5, 27. Add 5 again, 35, so on and so forth. Just addition of 5. That's arithmetic progression for you. Now, this is when it is addition. It could be minus. Let's take an example where it is minus. What happens? Let me take care now. Where it is minus, what happens? Let's now say if I move from 100, so let's say minus 5. That's 95. Minus 5, 90. Goes on. What will be the 12th number? Let's do it before I pick the numbers I want to do. Keep on minusing. 100. I want to set 95. 90. 85. 80. And give me 70. Sorry. 85, 80, 75, 70. If I take third, first, second, third, fourth, fifth, sixth. I want to use the two numbers to set now. First number, second, third, fourth, fifth, sixth. I want to set with this number third. So if given my third and sixth test of AP, second, find the first and common difference. I want to use the numbers here. 90 and I don't know how to frame the question now. Given that the third and sixth terms of an AP are 90 and 75 respectively. Find one, the common difference. Two, the first term. And maybe 3, 28th term. We saw it, I just prepared it. I say something from there. I keep on minusing 5. Minus 5, 95, minus 5, 90, minus 5, 85, minus 5, 80, minus 5, this. So I say I'm picking 1 and 2 to prepare the question. So given that the third and sixth terms of an AP are 90 and 75 respectively, find the common difference, find the first term and the common difference, and the 28th term. Let's now go. What I've done here just to give you how we frame the questions, how questions are prepared, and what you find in the textbook. Yes, you may be given 2 terms, the third and sixth, find the difference. Let's go. Third term equals A plus 3 minus 1D. Because generally n minus 1D. For third term, n now equals 3. So here becomes A plus 3 minus 1D. And therefore, A plus 2D equal the third term. You are told that the third term, your third and sixth terms are 90 and 75. So the third term is 90. So the question says A plus 2D equals 90. That's the third term. That's what I'm told. Using the same formula again, I can also get that the sixth term is the formula n equals 6. At the sixth term, n equals 6. So it becomes A plus 6 minus 1D. That's A plus 5D. And what is 5? I'm told that A plus 5, the sixth term, 1 is 90, 1 is 75. The sixth term is 75. So this is 75. So this question is answered. In other words, at the sixth term, A plus 5D now equals 75. Call the question number 2. Here, call this equation number 1. Where A plus 2D equals 90 for the third term, and also A plus 5D equals 75 for the. So I'm now going to use the two questions, questions 1 and 2. From questions 1 and 2, I'm going to subtract 1 quickly. Let's see. Let's say from questions 2, subtract question 1. Let's say from question 2, subtract question number 1. What am I saying? Here is A plus 5D equals 75, question 2. And the one says A plus 2D equals 90, question 1. So I'm going to subtract from equation 2. I'm going to subtract equation 1. This equation, of course. From equation 2, I'm going to subtract. That's what we have here. So I'm going to subtract this from this. What do you get? This one goes away. This one is 3D. And this equals minus 15. If 3D equals 15, minus 15, what is D now? I'll take it again. From equation 2, subtract equation 1. From this one, I'm going to subtract 1. Look at it. This I'll pick them. This minus will go. This minus will give me 3D. And 3D equals 75 minus which minus 15. Then let's solve for D now. Going over to this one, now solve for D. The first thing, find the common difference. That's the first thing I ask to the common difference. But my 3D now, if 3D equals minus 15, divide both sides by 3. Divide by 3, divide by 3. 3 goes there. Therefore D equals minus 5. 3 and 1, 3 and 5, minus 5. That's the answer number 1. So find the common difference. My common difference is now minus 5. Then from there, find first term. You now see, you recall that in equation 1, a plus 2 is 90. And now come in question number 2, we will recall that from equation number 1, a plus 2d equals 90 in equation 1. From that equation, I now know that my d is known. D is minus 5. I fit into the equation to be able to get a. Imply that, this is implies, it means that it goes to say, let me know this, that a plus 2 times minus 5 equals 90. Since my d is minus 5 here, therefore a plus 2, we say, we're getting in to a minus 5. When I recall from equation 1 here, a plus 2d equals 90. So we're now going to substitute this now, d for minus 5. Now, implies that a plus 2 times minus 5 equals 90. A plus 2 times is minus 10 equals 90. Because that is a minus 10 equals 90. Plus 10 to both, I move this across. Plus 10, then a now equals 90 plus 10. This is one. So I'm getting my common difference to be minus 5. My first term to be 100. Then what the other one is 20th term. Going back to the 20th term. 20th term, we now want the 20th term. In 20th term, equals a plus 20 minus 1, 19d. A plus 1, 19d equals 20th equals what? That's the question now. What's number 20? But I know that our a is what? A is 100. Common difference is 1 minus 5. So now put it here. A is now 100 plus 9 times 19 times d. This here minus 5 equals what? Open up 100 plus 19 times is minus 95. Yes, 95 equals what? Now that's 100 minus 95 equals what? And finally, you know that therefore 20th term equals 5. And then my is 5. That is 20th term. So our first term common difference is minus 5. Our working. First term is 100. And the 20th term, 20th term equals 5. You know, when I was setting, I say 100. Keep on minusing 5, 5. Say 100 minus 1, 95, 80, 85. If you do it, number 20, 20th number, 20th number will give you 5. That's what the phone is telling us. We're going to take more examples on this arithmetic progression. It can come in so many ways. So let's take another one. Assuming you're on a salary and you're told increases annually so. What will be your salary for the next 10 years? It's TAP. E.g., a man's salary is, say you have your salary and increase every January, incremental. And let's say for the next 12 years, how much will be your salary? Let's say your salary is 12,000. The man's salary is 12,000 per annum. And if it increases every year by 5,000 every year, then what will be the salary at the 6th year, or say 12th year, the 12th year? The salary will be what? What will be your salary? Because I don't know. A man is on a salary of 12,000 every per annum. Increases every year, increases. Increase by 5,000. Then at 12th year, what will be his salary? That's what I want. So we are going to use the formula again. L equals A plus M minus 1. That's the common difference. Where N now means the salary at the 12th year. Now the salary, I don't know. The first one is A. Let's come again first. Explain now and say, what is my A? A means the starting salary, 12,000. What is the common difference? How much is it increasing? Increases by 5,000. The N, the nth year they want. Say N equals 12. The nth year is the 12th year. So N is 12. Now looking it to the equation. L equals what? My A is 12,000. Plus N is what? 12 minus 1 times 5,000. So the L equals 12,000 plus 12 minus 1 is 11 times 5,000. Sorry, 5,000. For 12,000 plus 55,000. That will be the man's salary in 12 years' time. Add that will give you 67. Therefore, the man's salary will now be 67,000. That addition is right. Not add 50,000 is 67,000. That's the man's salary. Then also, let me take another example before we go to the sum of a GP. It's like they will tell you the arrangement of pole. Say, electric pole is arranged such that. Let's take it, let me prepare the question. I will say the question. As we are told that arrangement of pole is in the progression like this. Let's say we're adding 3. 1, 4, 7, 10, 13, 16, 19, 22, and so on. 1, 2, 3, 1, 2, 3, 4. This fourth number. 5, 6, 7, 8. The third number. First, second, just addition of 3 plus 3. That's what I've done. Plus 3, 7, plus 3, 10, plus 3, 13, 16. Now I'm going to use 10 and 22 to say the question. The electric pole is arranged such that electric poles are arranged such that the 4th and the 8th, so that the 4th and 8th poles are 10 and 22 respectively. Say 10 meters away. Find one. The first, just say find the first 10 poles. 1, 2, 3, 4, 5, 6, 7, 8, 9. Find the first 10 poles of it. Find the first 10 poles. Find the first 10 poles. Now, it's an arithmetic progression, yes. You don't know, it's AP, it's arithmetic progression. Because we are adding 3 constantly. I just need to say the question out. In textbook, you don't see this, they just see the question. I'm just telling how we derive this question in the textbook. Now, let's arrange. But then, I know that L equals A plus M minus 1 times D. And I told you that for anything you want, we are giving here the 4th and 8th poles. So the 4th pole, N equals 4. So N equals A plus 4 minus 1 D. That's N equals A plus 3D. That's 4th pole. And by this arrangement now, my 4th pole where N is 4. Now A plus M minus 1D equals what? M2. That's the 4th pole. That's why the electric poles are such that they are 10 and 22 respectively. So the 4th will take 10, the 8th will take 22. So the 4th pole equals 10. Then this equation equals 10. Or equation number 1. Now I know that's A plus 3D equals 10. Equation number 1. Now the 8th pole again, 8th pole. It's the same formula. At 8th pole, N equals 8. This equation A plus into N minus 1D. Since N is 8 now, A plus 8 minus 1, D is A plus 7D. And I'm told that the 8th pole is known already to be 22. So my A plus 7D now equals 22. Call it equation number 2. So I found equation 1 and 2. My equation 1 says A plus 3D is 10. My equation 2 says A plus 7D is 22. I can have some for my D, some for my A. From there now, we cannot get the first 10 arrangements of this post. Now let's go. From equation 2, subtract that. Let's see. From equation number 2, subtract equation 1. Equation 2, that's what I mean by the 7 minus 7D equals 22. That's equation 2. I'm going to subtract number 1, which A plus 3D, the 7, equals 10. Equation number 1. I'm not going to subtract. Go. I'll leave the numbers so that we'll come back to where we started from. If we got it right, we're going to get it right. Now, subtract. This A goes away. 7D minus this is 4D. 4D equals 22 minus this is 12. Now divide both sides by 4. 4. And 4D equals 3. You see, you are adding 3. That's what it's telling us 3. Remember where we started from. Now, what is the first term? And I say from equation 1, but in equation 1, add that A plus 3D equals 10. And I now know D to be 10. Therefore, A plus 3 times 3, of course, 3 times 3 equals 10. Well, 2 by 10. Therefore, A plus 9 equals 10. A equals 10 minus 9. Therefore, A equals 1. You now say the first pole is 1. And you have to be adding 3 to get your first. We are looking for the first. Having gotten the A, the first term A, the first pole, and the common difference, you cannot get as many poles. And let's say find the 10th term. So starting from 1 plus 3 is just bear the back of your mind, you are adding 3. Plus 3 is 4. 4 plus 3 is 7. 7 plus 10. Plus 3 is 13. Plus 3 is 16. Plus 3 is 19. Plus 22. Plus then 25. Plus then 28. Say first term 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's what I want here. That's all for AP, for addition. I want to go to sum of an AP. Because with sum and AP, there's always the sum of an AP. Up to that, being able to find X, find Y, and giving two numbers, maybe second and fourth term, find the rest, come it. And I want to go to the sum of an AP.